Okay, good morning, everybody. Uh, in my last class with you people, we started the frequency tables, right? And I talked about the ungrouped and grouped frequency tables. And I mentioned the Chebyshev's principle on sample size. What do you call it? Whether it is large or small. Is it not so? So I remember telling you that when the sample size is less than or equal to 30, is it small or big? Is it small or big or large? Eh? It's small, right? Okay, so in that case, let's now quickly continue. We took an example in that class, if I'm right, on how to use your group frequency table. Is it not so? So that example was example number 14. Was it 14? Please, let's start this class with example number 15. Now, I would love us to end that particular segment in today's class, because from the next class, our speed has to increase into other aspects we have to delve into. So let's quickly start with example 15. Yes, example 15. So organize the data below using an ungrouped frequency table. So I have here okay. So quickly let's organize that using an ungrouped frequency table. So as my solution, I'm going to have a table with I'm going to have a table with the following columns. So I'm going to have that. I hope this stuff gonna see. When I go down, you have to go down. So so our data entry column, we had said we use XI. Is it not so? Our frequency column, we use FI. But this time around, I want us to incorporate tallies like we used. Okay? So FI. Now I'm going to put here 1, 2, 3, 4, 5. Let's start with the first one. Let me even split this into I think this should be good. Now this is 20. You will notice that our values range from 20 to 30. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and then 30. Okay, so now that being said, let's now quickly use our tallies. I don't want us to dwell on this. Let's use our tallies. So I'm going horizontally. 21, I'll use one stroke, right? 24 comes in here, one stroke. 23, 28, one stroke. 21. Okay. Thank you. So 21 is 2. Thank you very much for that observation. 29. 21 again, right? Did we skip 29? I hope that's complete now. So we have 21, 24, 23, 28, and 29. So we've taken this 21 already. 30. 23 down, right? 24. 26. 26 again. 30. 28. I hope you follow what we are doing. 30. 25. 22. 23. 24. 30. 26. 27. 26. 29. 22. Okay. 25. 28. And 28 again. So we have no 20. I'll leave there blank. So it means 20, the frequency of 20 is what? 0. This will be what? 3. This will be what? This will be what? 3. This will be what? This will be what? This one, this one, this one, and this one is what? I hope this thing is capturing the board. Okay. Now, doing this means you have organized the data using an ungroup frequency table. Is it clear? Now, we took a definition on what we call tallies. And we say tallies are bundles of 5 or 5 strokes, right? Particularly slanty strokes that are used for counting values in a data set. Now, such that the first 4 strokes will be crossed by the 5th stroke to make a bundle of 5. Is it not so? Now, please, let's go with the next definition, because to this data, don't end your... We are going to take a definition, then you come back to that example. So I'm going to leave this space a little bit. Cumulative frequencies. Cumulative frequencies. I believe we also took a definition under the ungroup frequency table that frequencies in an ungroup frequency table refers to the number of times a particular data entry repeats itself or reoccurs. Is it not so? So now let's look at cumulative frequencies. I had explained this previously. Please, could you look up a little bit? I had explained this particular thing previously, that sometimes it may be required to get the sum of successive frequencies, not just the frequency of a particular data entry in this case. For example, a question like, how many 20s do you have in that data set? The answer will be 0. Is it not so? Because there are no 20s. Am I right or wrong? If you were asked, how many 22s do you have in that data set? You would say what? 2. Now the question is, sometimes if you are not required to provide the value of the frequency of a particular data entry, rather you are asked to provide the frequency, the total frequency of a successive number of data entries. What would you do? That gives rise to the concept of what? Cumulative frequencies. For example, it is under cumulative frequencies we answer the question, how many values range from 20 to 24? If I want to answer that question, how many values range from 20 to 24? It will be 0 plus 3 plus 2 plus 3 plus what? 3. If I want to answer the question, how many values range from 20 to 22? It will be 0 plus 3 plus what? 2. You get me? When you answer such a question based on the demand that you provide the total frequency for successive data entries, it gives rise to the concept of what? Cumulative frequencies. Is it clear? Now, please let's put this down. Cumulative frequencies. Cumulative frequencies represent the total frequency obtained for a sequence, a successive sequence of data entries. Okay, that's the first point there. Second point is that as a rule, the first frequency and the first cumulative frequency are equal. Meaning that if I ask you what is the first cumulative frequency there, it will be 0 because the first frequency is what? 0. You understand me? Also, the last cumulative frequency is equal to the total frequency. So if you add all the frequencies together, it will give you the total what? It will give you the last cumulative frequency. So I want us to do it together. Now, the last point I want to put here is this. The last point I want to put here that I want you guys to write down is this. Cumulative frequencies, therefore, please, I hope this thing is seeing this. Cumulative frequencies, therefore, may be used to answer the question. Cumulative frequency may be used to answer the question, how many values ranged from 20 to 23 in example what do you call it? Example, that was example 15, right? In example 15. So in this case, the answer will be obtained by adding the successive frequencies corresponding to the data entries 20, 21, 22 and what? 23. That is 0 plus 3 plus 2 plus 3, which gives what? Which will give 8. Do you understand what I'm saying? Now, first story under cumulative frequency answers the question, what is cumulative what? Frequency. So the first paragraph there answers the question, what is cumulative frequency? And we are saying that cumulative frequencies represent the total frequency, please, this should be past tense, so obtained. The total frequency obtained for what? A successive sequence of data entries. Full stop. So that paragraph here answers the question, what is cumulative what? Frequency. The next paragraph makes a remark on what you should know about cumulative frequencies. Is somebody hearing me? Yes, sir. It tells you that nobody ought to tell you the first cumulative frequency and the first frequency are always equal. So if your first frequency is 5, automatically your first cumulative frequency is what? Is 5. The second remark it makes in that paragraph is that when you add all your frequencies together, it will give you what is called total frequency. Am I right or wrong? The total frequency, as a rule, is equal to the last cumulative frequency. Is it clear? Now, come over again to the third paragraph. In the third paragraph, please, I hope you've been told in English language, every paragraph, a paragraph should convey at least 1 point. Do you understand me? And I like following that in putting up my paragraphs because each paragraph should convey a message, one strong message. In the third paragraph, what message am I conveying? In relation to this example, I'm trying to give you an illustration on what the definition is saying. So what are we saying here? Cumulative frequencies, therefore, may be what? May be used to answer the question in quotation mark. How many values range from 20 to 23 in this example? Now, if you come over to this example, this table, how many values were 20 in that data set? 0. How many were 21? 3. How many were 22? How many were 23? 3. Now, if I now ask you, how many values range from 20 to 23? It will be the sum of 0, the frequency of 20, added to 3, the frequency of 21, added to 2, the frequency of 22, added to what? 3, the frequency of what? 23. Is it clear? So that is the message I'm trying to pass here. That is why the cumulative frequency will be what? 8 for that question. Okay? Now, what do I want us to do? That being said, let us now get the cumulative frequencies. So I'm going to create an extra colon here and call it CFI and drag this one down so that we all can develop cumulative what? Frequencies. Okay? Now, rule. The rule says what, everybody? The first part of this rule. As a rule, the first frequency and the first cumulative frequency are what? So what would I put here? 0. You understand me now? Now, for us to get the cumulative frequency for the next cumulative frequency, it will be, the question we are trying to answer is how many range from 20 to 21? It will be 0 plus what? 3. So this will be what? 3. How many range from 20 to 22? Will be 0 plus 3 plus 2, which is the same thing as what? 3 plus 2. You see, 5. The next one will be what? 5 plus 3, which is what? 8. The same as saying 0 plus 3 plus 2 plus 3. The next one will be 8 plus 3, which is 11. The same as adding this, and this. The next will be what? 13. The next, 17. The next, 20 what? 2. The next, and the next, 20 what? Good. Now, we will soon be moving into something very concrete where you see the mathematics behind everything. If you add the total frequency now, 0 plus 3 plus 2 plus 3 plus 3 plus 2 plus 4 plus 1 plus 4 plus 2 plus 4, it will give you 28. Okay? And that brings me to the next thing I want to tell you here. Please look up, everybody. Now, please pay attention so that you don't read and think that we are developing some of these things for developing sake. The next paragraph I want to write here talks about notation. Is it clear? Let me quickly point you to what we had said earlier on. In my last class with you, I told you that data entries will be represented commonly with xi. And frequencies will be commonly represented with what? Fi. Now, where is the I coming from? For both X and F, it is coming from this. All of them here are frequencies. Let me use these guys in the front seat. Let the camera remain on the board. Now, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 persons in the first row. Right? There are 11 persons in the first row. So, I now, my focus is now on your height, or particularly your weight. If my focus is on your weight, in mathematics, I would say let a variable like W represent what? Weight. Represent weight. Now, that is the starting point. So if I start, where is my W coming from? It is coming from the fact that I want to consider weights, and I want to use a letter such as the starting letter of the word weight to represent what? Weights. Is it clear? But I now know that if W is used to represent weight, it now constitutes what we call a variable, because it is a variable in the sense that as I progress from the first person out of the 11 persons here to be considered, the weight will be changing. You may not have the same weight. It could be coincidental that 2 persons or 3 could have the same weight. It is normal. However, we are not expecting the same weight as we progress from person 1 to person what? 11. So I know very well that there will be 11 weights. I will come back to this symbol or this letter and then put WI. The I will now make a remark here. Please, it is very important. I will now make a remark here where I goes from 1, 2, 3 to what? 11. So, if a list is long, as you must have been told in set theory, currently you guys are doing MTH 101. So in set theory, they should have told you about a technique called listing or roster method in your set theory. So if this I here is called an iteration variable. It is the one that tells you that there are 11 persons here. As such, this variable should start from W1 to W11. Do you understand me? Now, if I move in this manner, this lady's weight will be my W1. And if her weight is 11, I'm going to write here W1 is 11 kilograms. For instance, I'm saying your weight will not be 11 kilograms in Jesus' name. Then, W2 will be the weight of the next person. And if I call that one 20 kilograms, I'll keep moving. Please, in mathematics, we always start with, if the list is long, we take the first 3 and use a conventional set of 3 dots. This is called ellipsis. Ellipsis is a conventional, it is not 3 dots separated, they go as one symbol. Ellipsis is a symbol. We have vertical ellipsis and we have what? Horizontal ellipsis. These 3 dots, whether vertical or horizontal, are called ellipses, and it is used to show that a counting continues to a fixed number in the end or indefinitely. Is it clear? So I have put 1, 2, 3 to show the pattern of the numbers, and I am ending it at 11 to show you that the number ends at what? 11. Is it clear? So in relation to this example, look at what is going on, because we are going to use it now. Now, please, this one is the first value. So it will be when I is what? 1. You see it? So this value 20 is the same thing as what? X1. The second value is what? X2. When I is what? 2. This is X3, X4, X5, X6, X7, X8, X9, X10, and what? X11. The same thing follows for what? Frequencies. This one is F1. This is F2. This is the frequency for the what? The third one. F4 up to what? F11. Now, if we tell you to add all the frequencies, we don't expect you to write them as long as they are. So we use a shorthand notation for writing the sum. The notation we use is the sigma. Okay? In statistics, there are 2 sigmas. All these are Greek. They are Greek. This is like uppercase. This is just like saying uppercase A and what? Small a. Is it clear? This is uppercase. Both of them answer the name sigma. In statistics, we reserve this one for standard deviation, population standard deviation, and population variance when it has a square on top. But this one here is reserved for what we call summation. So if I want to say I am adding F1 to F2 to F3 up to what? F11. We don't write like this in statistics. We don't write like that. What we do is we take Fi, okay, and then put what? Summation. And then show where the summation starts, that it starts from where? 1 and ends at where? You see it? So if you use that notation, it means what is proper to be written here will be summation from I equals 1 to 11 of all the Fi's. And that will give us what? 28. That is how we write. Okay? So what did I say? This is read as what? Summation of all the what? Fi's. Should I write it down? Summation of what? Of all the Fi's from I equals 1 to what? I equals 11. That's how we read that stuff. I hope you understand me. So please start getting used to it. We'll be using and we'll be needing it a lot. So, can I wipe it off? I'm leaving that one. So, but I can wipe this off, right? Good. Let's now progress. So that being said, let us now go quickly to group frequency table. Please, could you put your phone on silent? Group frequency table. I believe I can write, right? A group frequency table is one that organizes data entries in a data set using class intervals and their respective frequencies. So on group was using what? Data entries and their respective frequencies. Group will be using what? Class intervals and their respective frequencies. So that is my first point. Okay? Next paragraph. You remember we said that in an ungroup frequency table, frequency is interpreted as what? The number of times a particular data entry repeats itself. So we are going to make that remark here in my next paragraph, that in a group frequency table, in a group frequency table, frequency refers to the number of data entries, found in an interval. Okay, so it does not, if you see frequency for an ungrouped frequency table, it does not mean anymore that one data entry repeats itself 5 times. No, it means that if the frequency is 5, it means that there are 5 values in that particular what? Interval. Is it clear, everybody? So that is what it will mean. Please, can I wipe this off? So, we shall take the following definitions. We shall take the following definitions. So let's start with number 1. Class interval. Let's start with the first definition, class interval. Class intervals are groups of a data set. Groups of a data set into which data entries are counted by category. Class intervals may be equal or unequal. Full stop. Next, class size. The class size for any class interval describes the range of the interval. Describes the range of the interval. One formula for obtaining class interval, class size, also called class width, is given below. Can I wipe this off? It's given below. So please, let's put here class size is represented with small letter c, or if you don't use small letter c, use what? Small letter w. Is it clear, everybody? And it is given by the formula range all over number of classes required. Number of classes required. I will show you how to get that done. Range over what? Number of classes required. Now, next definition, class boundaries. Class boundaries. Sometimes certain values, certain raw values may fall out of specific class intervals. May fall out from specific class intervals and may not be accommodated. May not be accommodated. And may not be accommodated. What am I doing here? Accommodated in the next class interval due to approximations or other reasons. To ensure that lost values, the amount of lost values is minimized. Class boundaries are adopted. I remember explaining this before now. You remember that explanation I gave you about class boundaries when we were plotting the histogram? When I gave you an example of a particular value not being accommodated in a particular class and cannot even be accommodated in the next class, as such, you now have to introduce a plus or minus 0.5 value. Do you remember that explanation? So I'm saying that sometimes certain raw values may fall out from what? May fall out of specific class intervals and may not be accommodated in what? The next class interval due to approximations or other reasons. Okay? To ensure that the amount of lost values is minimized, class boundaries are what? Adopted. Is it clear? So based on that, we can now go to the next paragraph under that definition to define what it is. Class boundaries are formed when a plus or minus 0.5 value is added. A plus or minus 0.5 value is added to the limits of the class interval. Paragraph. In every class interval, there are two limits, namely the lower class limit, smaller value, lower class limit, and the UCL, larger value, upper class limit. In order to form the class boundaries, we subtract 0.5 from the LCL and add 0.5 to the what? To the UCL. Okay? Can I wipe this off? Then, next definition, class marks. Class marks, let me start with this statement. Computations in group frequency tables. In group frequency tables cannot be done directly. Cannot be done directly using class intervals. Cannot be done directly using class intervals or class boundaries. Please, all these we are writing, I'm going to explain all of them. You just need to have an idea of what we are doing. Is it clear? They are not useless. So if you want to carry out computations in group frequency tables, you won't be able to use class intervals. Neither will you be able to use class boundaries. Do you understand me? So what then do we use? So computations in group frequency tables cannot be done directly using what? Class intervals or class boundaries. Full stop. We use what are called class marks. Class marks instead. Okay? So, next paragraph. Class marks now represented as your what? Your xi. Is it clear? In group frequency table, your xi are now what? Class marks. So class marks xi are the averages of each class interval. That is, class mark xi is obtained. For you to obtain class mark, you add the LCL of a class interval to what? The UCL of a class interval and divide that value by what? By 2. Is it clear? Can I wipe this off?
Yes, sir.
Now, to end this class on the first topic, our first topic ends after my last statement. So in our next topic, we are going into measures of central tendency. We are going into measures of central tendency. We will move fast into measures of dispersion, then move into correlation and regression, and we will be very, very fast. Yes. Which one? This one? This one? Larger value. Larger value. Okay. Can I wipe this off? Okay. So, example number what now? Example number what? 16. Example 16. Now, please, our class will end with this example. I want to show you two things I will need you to pay attention to. However, in your exam, I don't know how your exam will be set. It may be set in such a way that I want us to look at the hardest form of how that thing can come, instead of looking at the simple form of how it can come. But in your exam, it may come in the simple form. That is, they may give you an organized table already. What if they don't give you an organized table? That is what I want us to look at. So, organize the data below. Organize the data below using a grouped frequency table. Organize the data below. Please, let's put it this way. Organize the data below into 5 classes. Using a grouped frequency table. Also, your table your table should show the following. 1, the following in this order. 1, class interval. 2, tallies. 3, frequencies. Okay? 4, class boundaries. 5, class marks. And then 6, cumulative frequency table. Cumulative frequency table. Cumulative frequency, sorry. Cumulative frequency. Thank you very much. Let me stop there.